Yeah, hello all. Welcome to the session. I hope things are smooth from your side. So in this, we'll try to understand. So we'll try to understand and revise the basic mathematics so that it gives some inputs where with confidence you will be able to attempt the qualifier exam and also subsequent sessions, right? So here, whatever the math that we are going to have is nothing but what we studied already, nothing new. It's just a recap. You need not worry. Suppose if we begin the discussion with some concept called as set theory, right? So immediately you can recollect what is the set theory, right? When we talk about collection of objects, right? Suppose it is something like if you are having the list of friends, right? If you write the list of all your friends and put it in this format, right? This is what we call a set, like 1, 2, 3, right? 4, and so on. Right? So that is the basic understanding of set. When we talk about set, it's a very easy to understand, right? So here the concepts are, one is how to write a set. This is one way that we can write. So if you recollect, this is nothing but numbers, right? Similarly, we can mention who are all your friends. List out who is your friend, like A is your friend, B is, C is, and so on, like, right? Up to Z. These are all your friends. So like this, we can list out all the elements and put in the braces. Then that is one representation of the set. Or otherwise, other way that we can write it as, here it is like X, where X is a number, X is a natural number. So then what we understand here, so we are going to have a collection of X, where X is a number, where we'll get X equal, the set as 1, 2, 3, 4, right? It is similarly X such that where X is a friend of mine. Okay. So like this, the one is listing all the elements in the set. Other one is how the set is defined. So these are the two kinds. Simply suppose if we ask, like, if a set is defined like this, where X such that X less than 10, X belongs to N, N means natural number. Right? Then if it is asked you to list out what are the entries or elements, then simply we understand X, and the nature of X is it is a natural number and also which is less than 10. That means we list out and say that 1, 2, 3, 4, and so on, 10, right? Or vice versa. Suppose if this is given, then we need to have this form, right? So this is called a set builder form, that is set construction form, how the set is constructed. And this is the list form, where we list out all the elements in the set, right? This is nothing new, right? If you recollect your our school math, this is what we discuss most of the times, right? Then what comes, the next is when we work with, suppose you had A is a person, suppose A is a person John and his friends, collection of his friends. Right? B is another set consisting of Sam and his list of friends. Now we want to understand many things. Many things means we want to find out on the whole who are the friends of A and B, right? If A is with some names, B is with some names. Those are friends of John, and B consisting of the friends of Sam. Now we want to understand, putting together A and B are having how many friends? Who are those, right? And second thing is, are there any common friends between these two? Whether John and Sam are having a common friends or not, right? So that is what mostly we understand or mostly we require. So that is where the algebra comes, that is operation. Operation means one is union operation, like A union B. A union means a join actually. This is what we call as join. Nothing but we club list consisting of friends of John and also friends of Sam. That is what we get as A union B. Now, when we talk about the common friends, who are the common friends of A and B, right? Then what we require is A intersection B, right? Okay, 1 minute, right? So A intersection B. Okay, so this is what very simple, right? Now this is a common friends. Now we'll try to understand this with an example. Suppose A is a set consisting of 1, 2, 3, 4, and 6. B is a set consisting of something like 2, 4, 8, 9. Right? Now we want to find all together who are the or what are the elements of A and B. If you want to have, then we talk about A union B. Right? That means now we list out 1, 2 is there in both, 3 is there in first one, 4, 6, 8, 9. Right? This is what we call as a join. Right? A intersection B means who are the common friends. That means common elements between these two, right? Then we list out 2 is there here, 2 is there here, 4 is there here, 4 is there here. That like this. So like this, we try to understand the set theory concepts. Now, one question here is whether A union B equal to B union A or not. Any answer? Similarly, A intersection B equal to B intersection A or not. Any answer? True, right? Now you can understand, so whether A and A friends of B or B friends of A, nothing but the same, right? Right? Whether you take the first A friends, then join B friends of B, or take friends of B, then join friends of A. But finally, we'll have the same set of friends, right? That's why these two are the same. Similarly, if you say A intersection B and B intersection A, right? So common either A with B or B with A, both are common, right? So this is one important property we call as. Any name for this property? A union B equal to B union A 2 plus 3 equal to 3 plus 2, 2 into 3 equal to 3 into 2. Any name for this property? Commutative property. Commutative. Right. So this is the basic requirement we need to have when we talk about set theory concepts. 1 minute, I'll try to remove this. Just give me a minute. Okay. Right. Now, one more thing is complement of. Sometimes we write like this, or we like this, or we write like this. So what is this complement? Right. So when we had the universal set means the set consisting of all numbers. Suppose if you take 1, 2, 3, 4, and so on up to 100. Right. If A is 1, 2, 3, 4 up to 10 only, right? Then mu minus A, that is the leftover elements. If you take A elements of A from the universal set, whatever we get is called as complement of A. Like this we write, or like this we write, or like this, all are having the same understanding. It means that take out this 1, 2, 3, and 10 from this parent set. Then what we get 11, 12, 13, 14, and so on up to 100. This is what we call as complement. Okay. Right. So this then next what we require is whenever we talk about set theory, this is, I think, I hope you recollect this. So this is what we call as Venn diagram, right? Venn diagram, what is this Venn diagram? Now, this is set A, this is set B. This is universal set. So here A union B, if you take A union B means the elements will either coming from A or coming from B or coming from both. That means In this, we try to understand this part as A union B. I hope it is clear, right? If you recollect the definition, what we had, A union B elements, either they come from A or they come from B or they come from both. That's why this part indicates A union B. Now, similarly, if you take intersection. Intersection means both, right? Now, if you see this part, right, this is common for both. So where this is called as A intersection B. Suppose A intersection B becomes 0, what happens? Any? If A intersection B equal to 0, what happens? If A intersects, that common part becomes 0, then what happens? Any guess? Nothing common, right? Very good. Different sets. That means if both are not having common friends, right? Then it looks like this, right? It looks like this and this. Then we call it as disjoint sets. Disjoint. There is no common part associated with this, right? Right. So this is what we require mostly when we work with set theory, right? Some numericals. Now I hope you understood what is A union B, what is A intersection B, what is complement. Now we'll play with these things. Play with these things means, suppose mu is given as some 1, 3, 5, 8, 9. Just if we understand this, we'll go with some numericals. That's the only difference. If A equal to 3, 5, 8, 6, 3, 5, 8, 9, this is. B equal to 9, 8, 10, something like this. Now we need to find what is A complement intersection B, or what is A intersection B, what is A union B, or what is A complement intersection B complement, like this. Once we understand these operations, we know, right, A complement means mu minus A, right? Then intersection, we know intersection with B. Similarly, we understood this. Similarly, we understood this, right? So once we had the basic understanding related to A union B, A intersection B, A complement, mostly what we do is we work with this, right? So this is what we talk about set theory. Okay. So any doubt? Disjoint sets, okay, good. Separate sets, okay, yeah. Good, nice. Any doubt related to set theory? Any doubt that you are having? None so far. Okay, straight aspect. Okay. Now, I hope you are comfortable, right? Set theory is very simple. If you understand the basics of union, intersection, complement, then we extend this. Suppose one more is given. Suppose A union, B union C if we want. The same thing. First, we take B union C. Then we go with A and go for union. Right? A intersection B intersection C. Suppose if we take common elements between B and C, then common with A. Very simple, right? Similarly, A union B intersection C, like this. Once we understand basics of union, very simple, we know how to find B intersection. We know how to join this with A, right? So that is what we can have in terms of set theory. Okay. Now, if we take this discussion, this is also a very simple concept, very, very simple concept. That is what we call as relations. So before understanding relation, we talk about something called as a Cartesian product. This is also very simple, very, very simple basic mathematics. Cartesian product. Suppose A, there is a set A, there is a set B. Then if we had a set collection of elements, very simple, A comma B, where A is coming from first set, B is coming from second set. Right? A cross B, where we'll have collection of pairs, actually ordered pairs we call as, this is called as ordered pair, where this first element is taken or coming from first set, second element is coming from second set. This is what we call as Cartesian product. So here, when we do this kind of Cartesian product, we can look for a relation that exists between these two. Means we can define something like this. If A equal to 1, 2, 3, 4, 5, B equal to 2, 4, 5, 6, then we want A cross B. If it is simply A cross B, then we'll have like this 1, 2, that is from this with this. Similarly, 1, 4, similarly 1, 5, similarly 1, 6. Similarly, with this 2, 2, 2, 4, 2, 5, 2, 6. Right? Like this, we can have 3, 2, right? 3, 4, 3, 5. This is nothing but Cartesian product of the set A and set B. But here, if we define something like A cross B, where x comma y such that x plus y equal to or less than 3. Right? Means what we are having from this Cartesian product, we want the pairs where pairs are having some relation, that is x plus y less than 3. Right? So then we need to take 1 plus 2, that is 3. So it won't be, maybe if I take less than or equal to 3, 1, 2 comes. 1, 4, 4 plus 1, 5. It is not less than, it is greater than, so it won't come. It won't come like this, right? So like this, we'll have collection of ordered pairs where there is a relation exists. That is what is a very simple, very simple. Suppose if you take two family members, right? X comma y. Now then we talk about the relation, right? X is father of y. Y is son of or daughter of X, right? So that is what is meant by a relation in a general sense, right? Okay. Right. Any doubts? Let me check chart once. Okay, you will have that doubts. Okay. So relation exists. Now, here our focus is more on the properties, which is very important for us. So properties are very important. So properties in the sense, reflexive property. Suppose there exists a relation. R is a relation because the collection of some elements. So when we say reflexive is, if every element is like this, if x comma x belongs to for R, then we say that the relation is reflexive. Next is symmetric. We'll try to understand this with an example. Symmetric. Whenever xy belongs to R, implies yx belongs to R. Okay. Then transitive property. Transitive property means there is a relation between x and y. There is a relation between y and z. Then there exists, if there exists a relation between x and z, then we say that the relation satisfies transitive property. So very simple. Suppose we know about parallel lines, right? Parallel lines, right? We know about this parallel lines, right? Our railway track is an example. Our electric wires is an example, right? In general, parallel lines. Now, if this is a relation, right? Is it reflexive? Suppose if you take a line itself is parallel to it, right? It is parallel to its own right. Therefore, this we say that parallel is a reflexive relation. Suppose there exists a line A, there exists another line. Now A is parallel to B, then B is also parallel to A, right? If you see here, xy belongs to R implies yx belongs to R. That means A is parallel to B. Then whenever A is parallel to B, then we say B is also parallel to A. That means it is symmetric property, right? Suppose we take this. There is a line A which is parallel to B. There is another line C which is parallel to C. B. A is parallel to B. B is parallel to C. Then we say, or we understand the first one and last one are also parallel, right? Then we say that it is transitive property. Right? So very simple to suppose if you take an example which is not, right? Suppose if you take this strictly less than is a relation, right? It will try to, it will help us to understand relation between two numbers, right? Whether less than or not, right? So now whether this is reflexive or not, any answer? Is it symmetric? Is it transitive? If it is clear. I'll come to some of the queries like weightage and so on, right? So what is the answer for this? Reflexive symmetric is false, right? Very good. So here, suppose if you take a number, it can't be less than to itself, right? Therefore, it is not reflexive. Suppose if you take 2, we know 2 is less than 3, but 3 is not less than 2, right? 3 is more than 2, right? Therefore, this is none. What about transitive? What is transitive? What about transitive? Is it yes or no? Oh, good. We can understand. Now we know 2 less than 3. That is A is relation with B. Next, another B with C. That is 3 less than 4. That is B is relation with C. And we know 2 is less than 4, right? That means A is in relation with C. That means this is transitive. Okay. So this is what is important for us. Right? So relations, particularly right and identifying what are the correct relations. Suppose if it is given in the form R equal to, R is from A to B, where A is given, B is given, and if it is defined like this, then identify what are the elements, identification. So that is what is important for us. Then next thing is properties for any given relation. Then whether it is reflexive or not, symmetric or not, transitive or not. So that combination, this is, I think, 2 examples we took to understand this, right? Okay. Any doubt or anything related to this topic? Very simple, right? If you say all these things are familiar to us, only thing is just we have to recap and feel that it is very easy, right? It's not so difficult, kind of, right? But only thing is we have to extend this understanding with some numericals. That's the only difference, right? Okay. So next topic we can take, I think very easy, right? This is nothing new, which we studied many times, right? Now we'll take the discussion further. With sequences and series. This is also one of the very simple and but very useful sequences and series. Very simple, very easy, but very good topic. What is this sequence and what is this series? This, I think, maybe the term seems to be something new for some people, but it's very simple. If it is nothing but arrangement of numbers, where if you, I'll write some examples, then you will identify. Any guess? What is the observation here? We had two numbers arranged, prime numbers VK, all are sequences. Any further observation? First one, if you see, what is that pattern you observed? What is the pattern if you observe here? What is the pattern observed here? And what is the pattern observed here? Yeah, particular pattern. Very good, Joyous. Yeah. What is the particular pattern? Odds number series, difference. If you see here, it's like for every term, the constant number is added to the next. Previous term, add some constant number where it is like, if you see here, 1 plus 2, 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 2, 11, right? That means by adding 2 to previous number, we are getting this, right? This is what we call as arithmetic progression, AP, arithmetic progression. There are many patterns, but our interest is the particular named patterns where it is something called as A plus D. If you see here, A plus 2D, A plus 3D, and so on, where this D is called as common difference. So this is arithmetic. Generally, we call it as AP. What about the second one? What is observed? What is the pattern we observed in the second one? Good, nice, right? So very simple. First one is adding a constant to each term, and we'll get the next. That is the pattern here. Second one is multiplication, right? 2 into 3. That constant, it should be constant, not different multiplication. The 3 is common. 2 into 3, 6, 16 into 3, 18, 18 into 3 is 54. That is what we call a geometric progression. Geometric progression, where we call it as, which is A into R, AR square, and so on. This is the general geometric progression, right? Where A is a first term, R is called as a common ratio. Yeah, this is. Now, well, small question for us. In this, what is the nth term if you go with? What will be the nth term? What will be the nth term here? Any guess? Any guess? First one, what is? Very good, Aditya. What is second one? A plus n minus 1 into D is what our friend is mentioning. Second one, what is the expected nth term if you go on writing like this? Here it is nth, what we call as nth term, A plus n minus 1 into D. We can check it if we want. N means term. If we want second term, that is n equal to 2, then 2 minus 1, that is 1, right? A plus D. Third term we want, that means n equal to 3. If we put n equal to 3 minus 1, that is 2, right? So in this case, it is A into R power n. Okay, now we can check it. First term we want, that means n equal to 1, put n equal to 1, 1 minus 1, R power 0, R power 0 is 1, therefore A. Second term we want 2 minus 1, that is AR. Third term 3 minus 1 is R square. So this is. Now what about the third one? Third one is not a unique one, but is also having some name associated with it. Yeah, very good. AR and minus 1 shown. Yeah. What about third one? If you see here, third one is nothing but something related to first one, right? 1 by 1 by 1, 1 by 3, 1 by 5. This is nothing but reciprocals of AP. This is what we call as HP, harmonic progression. Harmonic progression. Right? This is what. Okay. So this is what, there are many, but many patterns, but these are the named patterns, popular patterns, which are very useful, helpful for us throughout. Okay. 1 by a plus, yeah, 1 by a plus n minus 1 into d. So I hope it's clear, right? So three things we had. One is AP, where it is a plus d, a plus 2d plus so on, so comma, a plus n minus 1 into d. This is nth term. GP, A, AR square, so on, AR power n minus 1. This harmonic progression, which is 1 by A, 1 by A plus D, 1 by A plus 2D, 1 by A plus n minus 1 into D. Okay. So how to, only thing is, first we need to observe what is D, what is R accordingly. Very simple. Suppose this is given 2, in this series, find 30th term. Not by writing it completely. So you see, this is not a advised kind of, right? Keep on writing is not the requirement here. If this goes like this, keep on continuing. What is the 30th term we can see without seeing 29th, 28th, 27th, and so on. We want to jump into 30th term directly. How to find it? Right? Now immediately we understand, right? 30th term is a plus n minus 1 into d, right? That means a plus 30 minus 1, right? Into d, right? That means a plus 29d, right? Now what we need a, we need d. What is a here? A means first term. This is a, right? 2 plus, what is d? What is the standard number we added to each term, right? 2 plus 3, 5, 5 plus 3, 8, 8 plus 6, 4. The common difference is very simple to have common difference. If you take difference between these two in the reverse, not in the progressive way, 8 minus 5, 3, 5 minus 2, 3. So therefore d equal to 3. Like this, we need to just practice few problems related to numericals associated with these things. Now same thing we can work out in terms of geometric progression. Any doubt? Let me check before proceeding. Yeah, 89. Very good. Nice. So nice. Okay, good. Right. Now, if you say whatever we discussed so far is everything is known to us. Just a recap of the things and keep something like some mass is always something which haunts us with so many formulas, right? No, it is not so. Okay. Yeah. Clear, right? So now numericals, suppose sometimes what happens, right? Sixth term is they give, we know sixth term, we know eighth term, some number they give, exactly I'm not, suppose it's 48, if it is 56, something like this, then find 12th term. Like this. We know sixth term means a plus 6 means 5d. 5d equal to 48. 8th term means we know, right? 7d comes, right? 7d equal to 56. Now we'll solve these two, right? We know to find 12th term means what? A plus 12 means 11, right? 11d means we want a value, we want d value, which we can have from this, right? If you subtract these two, a minus a goes, that is a minus a becomes 0. 7d minus 5d means 2d. And 56 minus 48 is 8. Then d equal to 2 4s are 8. Once d is there, if you substitute, we'll get a value, right? If you take this a plus 5d, 5 into 4 equal to 48. That means a equal to 48 minus 20. That is 28. Very simple, right? We had a, we had d. Just plug in the values here. We get the required term. Now, same thing we can do even for geometric progression. Same we can do for arithmetic progression and so on. Right? Okay, so very simple, right? nothing that is very difficult, right? Yeah. Now you can calculate it. Okay? 28 plus 11 into 4, 44, 52, 72. Yeah, perfect. Okay. Right. Now you tell me, is it so difficult? Do you feel that this basic math is so difficult? No, right? Right, good. Nice to hear. Right. If you remove that, then it's very easy. Now we'll get into something which always haunts us, like complex numbers. Maybe this is something which we learned in higher classes, not in lower classes, right? Yeah, very easy, right? Complex numbers. What is this complex number? We know about numbers, right? So we know about number systems like natural number system, right? Integers, positive integers, negative integers, rational numbers. So many things we know, right? Then extending this further, there is something called as complex number system. What is this complex number system? Any guess? Anything? If you are aware, you can. Very simple. If A and B are two real numbers, then A plus IB is the complex number. Here, what is I? A plus IB. Yeah, very good. Very good. Square root of -1, where this I equal to square root of, because this is having some useful applications in engineering. That's the reason I equal to root -1. Okay. Where when we talk about this complex number system, then yeah, imaginary number. Yes, very good. So here AB are nothing but our numbers only, our friends only. AB are our regular friends only, but the combination of both together is nothing but the complex number. Okay, where this is called as a real part, and this B is called as imaginary part. Like very simple, right? Suppose if we say -2 plus 3i, so this is the real part, and imaginary part is 3. Okay. Now it's a very simple actually. Suppose if I ask a simple question like, what is the real part of what is the real part of this? If you see here, this is nothing but this is a complex number, right? This is A plus IB, this is A plus IB, this is A plus IB. That is nothing but addition of numbers, 1 plus 2 plus 3 kind of thing. But how to add complex numbers? Very simple. Here, very simple. First, add real parts. So real part means we know, right? This is 1 plus 2 plus 3 is the real part. Plus I into, then add imaginary part. Now this coefficient is 1, right? And this coefficient, this I's coefficient is 3, right? And here it is 2. Now you see here 6 plus 6i. This is how, just like what we do in case of our regular numbers, similar. But the only thing is all grouping, all real parts, and next all imaginary parts next, like this we do. Now suppose if I go with multiplication, suppose 2 plus 3i, very simple actually, but generally we are scared of this topic, but very simple. Now we want to multiply. This is a complex number, this is another complex number. We want to multiply it. How to multiply it? Simple multiplication only, right? Yeah, very good. 6i. Yeah, 6 plus 6i. Good. Yeah. So now just I want answer like this. What is real part of this? Real part of this complex number. So here it is a product, right? First multiplication, simple sense, how we multiply in general, right? Now 2 into -3, that is -6. 2 into minus 3, then 2 into minus 2, that is minus 4i. Next 3 into 3, minus 9i. Next here we have to be very careful, plus 3i into minus 2i, that is 3 into minus 2 is minus 6, into I square will come, right? But we know I square is how much? I equal to square root of minus 1. When we square it, what happens? It becomes minus 1, right? So I square is always minus 1. Then what happens is minus 6, minus 4i, minus 9i. This minus minus becomes plus. Then nothing but first group real parts, minus 6 plus 6. Then you can take minus common, then 4 plus 9. Then we get as 0 minus 13i. Okay. Now we can have real part is 0. Imaginary part is minus. Here real part is missing, right? Then we call it as a pure imaginary. Is it called as purely imaginary? Okay, very good. 0, right? Very good. Just playing with complex numbers, nothing else. Suppose if it is a division, if it is a division, then what to do? Okay. We'll take it an example. We'll try to understand it. Now 2 plus I by 1 minus I. So this is a complex number. This is a complex number. How can any guess? How can we do this? Even without studying it earlier, also we can try. Yeah. Rationalize first. Actually, rationalize now. Very simple thing, right? How can we get out of this I in the denominator? So how to get out of I always? If we had I square, right? We know I square can be replaced by minus 1, right? Right. So here, how to have I square in this place? Our friend mentioned rationalize. What does it mean? We know a plus b into a minus b gives, right? A square minus b square, right? Now I hope you understood, right? So now if 1 minus I is there, then we can if we multiply it by 1 plus I, then it becomes a plus b into a minus b, then a square minus b square. That means I square comes here, right? Therefore, there won't be any imaginary part or imaginary number in the denominator. Then very simple, right? I think, right? So that means first we have to see, then we have to, if a plus b is there, we have to find what is a minus b. We have to multiply and divide it. Here 1 plus I by 1 minus I. Okay. This is. Then when by doing this, we use one term called as conjugate. Or some people call as complex conjugate. Very simple, very simple. Suppose if z equal to, I'll write 1 plus I. Then if suppose 1 plus I is there, with what we will multiply? We go with 1 minus I, right? That is called as is complex conjugate or simply conjugate. That means a plus ib is the complex number. Its conjugate is a minus ib. Very simple, right? This is one of the important terms for us. That helps us to do the division of complex numbers. Generally, just remember this. This representation indicates conjugate. Okay. Now it's very simple, right? Denominator, if you go for a plus b, oh sorry, this is plus, right? Same thing, 1 plus 1 minus I, its conjugate is 1 plus I. So multiply the numerator and denominator by this. Then by doing this, what we get is here a minus b into a plus b. Then a square minus b square, 1 square minus I square. Numerator is not a problem. It's just simple multiplication, right? 2 into 1, 2 into I, 2i plus I into 1, I plus I square. Now we can write 2 plus 2i plus I square we know, right, as minus 1 by 1 square is 1. Here we know I square is minus 1. This minus of minus plus 1. So that is, now this real part is 2. Here real part is minus 1, 2 minus 1. plus take imaginary part I into 2 plus 1. That means 1 plus 3i by 2. This is now same question we can be asked like, what is the real part of 2 plus I by 1 minus f? That means first we have to go for division. That is, first we have to identify conjugate of the denominator, multiply numerator and denominator by the same and do this. Finally, we'll get this. Then what is the real part of this? 1 by 2. Suppose if we ask like imaginary part, right? Then it is 3 by 2. Okay. I hope I understood what is this conjugate, right? Any doubt here? Anything that you want? Very simple, right? Now you can understand what is z in general. Suppose z equal to a plus ib, then what is that we get by doing this? Any guess? Z into Z conjugate, right? I think you can imagine, right? Z means for us a plus ib, right? Conjugate means a minus ib, right? Then it is a plus b into a minus b, a square minus b square, a square minus ib whole square, a square minus I square b square. I square is minus 1, minus minus plus, therefore a square, like this. Like any combination, I hope you understood. Very simple, very good, very good. Right? So in complex numbers, what are the things we need to understand? What is meant by real part? What is meant by imaginary part? How to add complex numbers? How to multiply complex numbers? How to divide complex numbers? Right? Very simple, right? Next, one more term what we use, absolute value. If z equal to a plus ib is the complex number, then its absolute value, that general we denote by modulus, is nothing but square root of a square plus b square. Okay, this is what we call absolute value of. Now I think you can play with numbers. It's very simple, like multiplication, division. But only thing is, it need not be one or two combinations. Suppose, what is the real part of 1 plus I into 1 minus I into 2 plus I? That's it. We know, right? We have to multiply all these things and write it in the form. Then we can give what is real part, what is imaginary part. Similarly, what is imaginary part of something like this? So we have to complete. Or sometimes it can be, what is the complex conjugate of? Complex conjugate of this. So carefully, already we know how to do this, right? Multiplying it by 2 plus I and simplification. Suppose by doing this, we are getting something like, suppose we know how to do this and how to get this. The multiply here 2 minus I, conjugate is 2 plus I. Multiplying here and here by 2 plus I. Then numerator, simple multiplication. Denominator a square minus b square will get. And if you simplify, suppose we are getting this. Then what we want is complex conjugate. If minus 2 plus 3i, then its conjugate is minus 2 minus 3i. Okay. So like this, we can understand complex number system. I think very simple, right? So if you want one more point also, I'll add here amplitude. That is, actually it is a theta. Okay. Z equal to, just a minute. A plus IP. Then we can have the angle that is tan theta equal to B by A. This is what we can have. This is what we call it tan theta. So B by, that is complex part by imaginary part, is nothing but tan theta. Actually slope comes into, but we are not getting into the discussion. Simply for a given complex number, we can have two things. One is absolute value, other one is amplitude. The angle that it makes is nothing but tan theta, which is B by A. Okay. Next is very simple concept, quadratic equations. So what is quadratic equation? Any guess? Very simple, right? Suppose x square minus 3x plus 2 equal to 0. Here, the highest power is this. Right? So this is what we call as x square degrees 2. Very good. Degrees, highest degrees. Now, this is very important for us. Now, we need to find values of x and y, which satisfies this equation. That is by putting what value for x. Suppose if we take x equal to 1, if we put, then 1 square minus 3 into 1 plus 2. That means 2 plus 3, 2 plus 1 is 3, 3 minus 3, 0. That means satisfies. This x equal to 1 is called as a root. Right? Okay. Here, how to do this? Not that every time, here we know it, we are doing. Then, oh, sorry, 1 minute. How to find the roots of a quadratic equation? Right? How to find? One is factorization. If factorization is not possible, then instead we go for this minus b plus r minus under root of b square minus 4ac by 2a. I hope you recollect this formula, right? If ax square plus bx plus c equal to 0 is the quadratic equation, then x we can have by using this formula. We need not go for factorization. Just a minute. I'll arrange and use this part. Okay. So very simple actually. Ax square plus bx plus c equal to 0. Then x equal to minus b plus r minus under root of b square minus 4ac by 2a. Okay. Quadratic formula. Use Sridharacharya formula. Okay, good. Minus b plus r minus. So here actually this term is something important for us, right? So what is that it tells us is, so without solving it, sometimes what happens is we don't want x values. We want to find what kind of roots it will have. So that depends on this. Suppose here, if b square minus 4ac greater than 0, then what happens? If this value becomes 0, greater than 0, then what happens? Some number 4i, 5i like this will get real roots, right? Real roots. And here plus or with plus one root we get, with minus we'll get, at least two different real roots we get. Two different real roots. Suppose if it becomes less than 0, what happens? If b square, already we have seen, if it is a negative in the root, it becomes complex number, right? It becomes a complex number, right? For example, I'll take it as minus 1 plus or minus under root of minus 2 by 3, suppose. Now we know, right, this is nothing but minus 1 plus or minus root 2i, right, by 3. Because under root of minus 1 is I, right? So that means if b square minus ac less than 0, then we'll have complex root. Any observation when we are going for complex roots? Any observation? Or otherwise I'll write here. What are those two roots here? Minus 1 plus, one is with plus, other one is with minus. Then anything that you recollect immediately? Whenever complex, what happens? Conjugate. Okay, that means suppose I want check with, like, suppose if I ask a question like, if a square for a quadratic equation ax square plus bx plus c equal to 0, one root is given as 1 plus 2a. What is the other root? One root is 1 plus 2a. What is the other root? You generally what we'll think is, sir, please give a value, b value, c value, I will substitute. And but no, we are not having any abc values. We know for this is a root. Then we know for always when the complex roots it is having, they are conjugates. The 1 plus I is one root, then immediately what we say, 1 minus 2a. Right? So this is the trick here. Okay. And one more important discussion here is, maybe slides over. 1 minus 2, I think clear, right? This is right. We'll use this. We'll try to understand something like, suppose x minus 1 into x minus 3 equal to 0. Just multiply this, x square minus 3x minus x plus 3 equal to 0. If you see this, x square minus x into 1 plus 3 plus 1 into 3 equal to 0. What I mean to say is, here x equal to 1, x equal to 3 are the roots. If x equal to 1, x equal to 3 are the roots, how the equation looks like is, if you see x square minus x into sum of the roots plus product of the roots. That means what I mean to say is, till now what we did, equation is given, we try to find the roots. But if roots are given, how to find the equation, right? Suppose this is how we use. If alpha, beta are the roots, then what is its equation? X square minus x into sum of roots plus product of roots equal to 0. This is one important thing for us. So clear, right? This is about complex numbers. And when our quadratic equation means, so immediately what should come in our mind is minus b plus or minus root of b square minus 4ac by 2a. Sometimes what is a value, what is b value, what is c value, substitute and find the roots. What are the values and substitute and find out what are the roots. Second one is types of roots, right? We are not going to solve it, just we'll try to find what is b square minus 4ac. There we'll try to see whether it is greater than 0 or less than 0. One more point we missed is equal to 0. So here x equal to minus b plus or minus under root of b square minus 4ac by 2a if you take. In this case, real different roots. In this case, complex roots will get. And most importantly, complex number and its conjugate are the roots here. If equal to 0, if this becomes 0, what happens? We'll get real roots only, but roots are the same. That is, same roots we'll get. That is minus b by 2a and minus b by 2a. For example, if we take x square minus 2x plus 1 equal to 0. X minus 1 whole square, this is, that means x equal to 1 comma 1. Right? You can check here, b for this b square minus 4ac is 2 square minus 4 into a is 1, c is 1, that is 4 minus 4 equal to 0. So b square minus 4ac equal to 0, then we'll get same roots or repeated roots. Okay, this is how we can understand the nature of roots or characteristic of roots, right? The other one is when the roots are given, how to formulate the equation corresponding to. This is how x square minus x into alpha plus beta and alpha beta equal to 0. Okay. Okay. So almost I think we covered except the calculus part. Anything from your side? Calculus part, I think very simple. You need to go through the formulas, integration formulas, derivative formulas, right? Limits formulas. Just is a playing with formulas only, right? What is the derivative of sin x? What is integral of cos x, right? Then a combination of. Okay. Yeah. So weightage here almost all are having equal weight. Only thing is same here. You will just have to use a simple approach. Sometimes you have to leave some. Sometimes you'll have a lengthy expressions, lengthy kind of queries, right? Just leave them and proceed further. One is you need not waste your time for it, and second one is if a wrong attempt takes your marks, right? That is the only art of writing examination you need to practice. Weightage is almost same. Suppose sometimes what happens now, if you in trigonometry, I think one more topic that what we had, trigonometry. In trigonometry, better avoid any lengthy application, heights and distances kind of thing, which consumes more time, right? So avoid it. Just that's why set theory, relations, functions, sequences, complex numbers, quadratic equations. These are all trigonometry. Also, basics of trigonometry is very, very simple, right? And even limits and differentiation also very simple. But whenever you see complex differentiation, leave it. When time permits, at the end, come back and do it. No need to remember, right? No need to remember. These are all very simple. We learned in as a kid only, right? Very, very simple. You need not remember most of these formulas. I think our team will explain. Like I think you can use. I think you can use because it's basically it is a math, right? Where you need to work out. I think this information you will get, Pratham. How many questions and weightage. It is not JE. If you see this is a basic understanding of math. Now, the approach, the math that what we are going to test or what we are going to have is a guy who wants to get into computer science, right? That is the approach here. That's why maybe you may find some difficult questions. That is how we try to balance. Otherwise, it is not like a JE exam. It is just like our board exam. It is a more extension of your a basic school with some extension towards plus 2. Yeah. Okay. Yeah.
Hello, Professor YVK Aditya. Thank you very much for a very detailed and easy to learn session. I think even I refreshed some of my concepts.
Okay, thank you.
Thank you. Yeah, I think the students are also now more clear about how to prepare, and I think the exam is a very simple one. It just tests your basics. If you know all of these, if you just go through this recording and go through some of the resources, I think you are well placed to be able to clear the exam. There is a sample paper which is there on the on our application page. You can find the link there. Even the registration link is provided there also. So there'll be 40 multiple choice questions over 2 hours, and each correct question will have 4 marks and -1 for incorrect answers, you'll have to score 40% to clear, which is 64 marks out of 160. And you can use a rough paper to do your workout and things like that. Yeah. I think I got most of the questions.
Can we keep a list of formulas with us? Ajit, someone is asking.
I don't think you can use any references like that, but I think some of the basic formulas you should be able to remember. I don't think this is going to test you on very advanced levels.
No issue, I think. No, the AI will take care of that, I think. If I am using a paper and whether it will identify something like this asking. So don't worry about that aspect if you are not going.
Yeah, there will be a proctor. So I think if there's any issues, they may contact you, or you can tell them what to do. No, so this math exam is just a single camera exam. I think this is basically going to be looking at you or seeing if there's someone else around you helping you. So I think as long as that is clear, I think you should be good. JEE is a very tough exam on very advanced concepts. This is just testing the basics. So it's more of a multiple choice type of test. You solve the problem, you pick one of the one of the options which you think is the correct answer. And this test is not meant to eliminate applicants like JEE. JEE is trying to find the top 500 out of the lakhs of people who are applying. In this case, it's just to ensure that you have the basic skills required to be able to pursue this degree, study, participate, and graduate successfully. Because there is a math component in the program, since this is a technical degree, and many of the people whom we are asking to write this exam don't have that proficiency at the level that we would want. So this is just a means to, one is to ensure that you prepare, and the second is that you'll also refresh your concepts.
I'll add one point in a lighter note, Ajit.
Yes.
So here, math will have two approaches actually. One is just like if you are learning a two-wheeler for a general purpose, how you learn. If you want to become a racer, right? If you want to become a racer, the skill set, the approach, what you need to have is different from if you want to have your two-wheeler ride in a regular fashion, what you'll have, right? So here the math, what we require is a regular bike rider. We are not getting into race, right? That's why it is not going to have, we don't require lots of complex issues as a part of this, right? That's why don't get into racer kind of mode, feeling that math is very difficult. So we are not going in this direction. That's why it is not like a JEE examination. It's not a racer kind of requirement. That's why. So this is the path we are going towards. And accordingly, we are going for a basic math required, right? So have that approach, then you feel that it is very easy to attempt most of the questions, right? Yeah. Yeah, thank you.
Thank you, sir. Good analogy.
Yeah.
So for the qualifier exam, we will be opening another day, another slot again on 15th. So in the unlikely event that you're not able to clear the exam this time on 8th, you will get another attempt also. All right. You can attempt it 3 times. So right now there's going to be another slot opening. So presently there's 2 options available. After you register and pay for the exam, you'll get a link with your credentials, and there'll be a mock test to test your system and all those things.
In calculus, it is basic limits, continuity, differentiability, and integration. It's not like complex integrations, like basic stuff, right? Integral of sine x plus cos x, those basic calculus is what we are going to have.
Yeah, I think if you just go through the basic formulas, you'll get it. You can just sort of try to memorize maybe 10, 15 types of basic formulas, and you'll know exactly how to.
Okay.
Offline MS from BITS is possible. If you higher studies in BITS, you'll have to write the BITSAT exam also. So there is a qualifier exam for offline, for on-campus masters. But yes, this bachelor's, if you do the 4-year one, you'll be eligible.
Harun, that's I think you don't require that much time. Just spend maximum of 3 to 4 hours, recap all the things, then you will be able to do it.
Yeah, I think why do you want to wait for the next batch? You're going to lose 6 months in that. And so my suggestion is you try these 2 attempts. If you're clearing 40%, you'll be on your way to starting your thing right now. Yes, of course, if you don't clear, then you can always prepare and apply for the next batch. But
what I suggest is
now.
Maximum of 4 to 5 hours you spend and recap the things. You will be able to attempt many of the questions, because this is the basic math what we learned many years.
Sir, so I actually haven't touched maths in 15 years, right? And I dropped out of engineering many years ago.
But even then, cycling, swimming, and math, these are the things which we never forget. It will be there in our blood. Only thing is a recap.
Right. So can I, I haven't applied yet because I thought maybe preparation will take long. That's why I did not apply. But if you're saying that it's possible, then I would like to, take this week and prepare. Is it okay to apply again?
Why don't you take this 8-12 attempt and see how you score? There's no downside to it.
Right. And then if I like clear, will I be able to apply? Because I thought
yes.
I thought the date was 2nd or 6th or something last date.
No, it's extended to 10th is extended deadline now. So this thing is, if you're not, so I'm guessing all of these people in here are already in the math qualifier category. So you would already have all the details. You just have to go in there, pay the amount, and register, and you'll get your credentials by tomorrow evening, and you just go and take the test. So even if you don't clear it for example, you still get an idea about it. It'll be like a mock test for you, and you'll have another week to prepare for the 15th.
Right. So
and again, as Professor YVK said, you don't have to score 99 out of 100. This is not an entrance exam.
Yeah.
If you score 40, you're good.
Yeah. So the next exam is on what date?
It will be next Saturday, 15.
And okay, so I'll apply now, and I will have to apply for BITS as well as for this qualifier exam.
BITS, you've not applied yet?
I haven't.
Yeah. So I think you submit your application. Hopefully tomorrow morning our team will. You can also, in that case, if you don't have the math, you can register separately. I think the link is there on the website. So you can register with your same email ID and name and phone number. Your application ID, you can just put your phone number only for your application ID.
Okay.
And we'll be able to reconcile that.
All right, I'll do that. Is there somebody I can reach out to as well if I am not able to, manage?
Yes, sir.
You can write to admissions at online. There's an email ID.
All right. Thanks.
Hi, sir.
Yeah, go ahead.
Hi, sir. Next attempt is data.
It's 15th. So we didn't open it right now because the moment we open it, everyone will opt for 15th and no one will take the next one. So we're waiting until tomorrow and we'll open it.
So in case we have to attend on the 15th, will we have to reapply again? And then go to the
So my suggestion is if you're planning to take it, take tomorrow the one on Saturday, this Saturday 8th.
Of course, yeah.
Yeah, and then we'll open something up. So once you get the results, you'll know by Saturday itself, or if you don't see the score or don't remember the score, you'll get to know by Monday, and then you can register for the next one.
Okay. In which case, I'll have to reapply, correct?
Yeah, go ahead and apply. There's no downside to this. So this is primarily why we set up the session, because we noticed that there's a lot of people just sitting in this bucket and not registering. So we just wanted to make sure and take professor's help to reach out to you to tell you that this content is not really hard. It's just that you have to take this first step and register, do a few hours of prep, and I think
Yes, will I get the recording available?
Yeah, this recording will be shared with everyone who registered for this event. So we'll share it by probably end of day today.
Thanks.
Yes, Pau Jain, yes. You will get, obviously will be alumnus of BITS. You will be a part of BITS family once you finish the program.
Yeah, you'll be an alumni, you'll get access to the alumni association and all that.
You can enjoy BITSian Day every year.
Just a question I have, for the exam that we have only covered the sets and the quadratic equation, is there any way that we can get a class on the calculus? Because I have not touched the math for around, we can say 16, 17 years now. I'm a working profession. So is there any way that we can get a class on calculus specifically? Just like a simple highlight on the calculus, because I've seen the question paper. It's not that tough, but at least a heads up would be much more easier for us.
We'll think, and maybe Ajit tomorrow tomorrow we can plan for a half an hour or 45 minute session if it is okay.
Sure. Yeah, if you're free, we can.
Yeah, not a problem. Always we are good to go with people who are eager to learn.
We are good for extra classes.
Not a problem.
Not a problem. Thank you very much.
Otherwise, also you can definitely look on YouTube and other stuff. There's a lot of resources there, and I think we've also given links to the CBSE textbooks for calculus. You can look at that also. So most of, all of those resources.
The textbooks which are provided here, I think it is majorly related with complex number, quadratic equation, sequences, and trigonometry. Calculus, the part which you have given, it is related to a video on Coursera, which is pretty long. So see, the thing is that basically for us, it would be very much difficult to concentrate for around 5 or 6 hours continuously in one subject. So a good hands-on or heads up of around 45 minutes or 1 hour to get the basics in place, that would be really helpful.
Sure, we'll discuss follow-up session. We'll see the logistics of that and we'll arrange. But in any case, you register for the exam this weekend. I think that's the most important takeaway that we want to say, that you have only 2 slots left. So try to make the most of it. Register for the one. If you clear, that's great. Otherwise, it's a mock test for your next one on 15th.
Okay, sure.
I think Joya, you are having some query.
I'm not seeing a message.
Raising hand, I think that's fine.
Okay. Calculator is allowed. I think the exam platform has its own calculator you can use. Or you can solve it on paper. I don't think we have really complicated calculations happening or that you can use a calculator for.
Hi, sir.
But,
hi, sir.
Yeah. Go ahead.
Hi, yes, sir. Is the exam is a smartphone accepted?
No. You have to do it on a system.
Huh?
You have to do it on a system. You can't write exam on a phone.
The smartphone is no laptop in.
No, you will require it because if you're joining the program, you will need a laptop or some system.
Learning is yes, sir. But time is no. Yes, time is no.
Okay.
So I don't think this will work on a phone. So I don't think the software.
Yeah, it won't work.
Yeah, you'll either try to borrow your friends or see if you can get from some relative or something.
Yes, computer is accepted.
Yeah, desktop, laptop will work. Webcam is
Yes.
required.
Camera is required.
Yeah, yeah.
Yes. Okay.
Yeah, thank you, Karthik. Nice.
Yes.
Hello. Hello, sir. Am I audible to you?
Yes.
Hello.
Yes.
Yes,
Go
sir.
ahead, please.
Actually, sir, my laptop is not working properly yet because my laptop is facing some kind of hanging issue, and if some reason my connection is lost, my laptop gets freezing. What would I do, sir?
Generally, I think it will log out. It may terminate your test, but try to make sure that you have something which is reliable. I'm not exactly sure because how that software will work.
If some reason actually my laptop is get freeze and the timer will be start stunning now that time.
That I'm not sure about. And those details, I think once you register for the test, you will get some instruction. So that will explain the thing. But try to get a reliable thing.
Sure,
Because
sir.
anyway,
Because
you're
my
trying to
current
give a math
PC is
test. I think the laptop should also at least be working. Otherwise, you're dealing with two different sets of problems.
So, Subrajit, I think yes. If any technical issue happens when you log in, you can continue with the time. It takes care of the time that you lost.
Sir, when we apply, it says that we must keep a backup option. So if any technical issue occurs, we can change to the other device and log in again, right?
Yes,
You
yes.
should be able to do that. It will be so again. There's all. I mean, you'll have to check with the proctors and all. So if there's a problem,
Yeah, but
there's a help desk number. So you'll get all the details. So I will not be able to give you all the details about the technical aspects of the exam. That you'll get a separate.
So in that case, I can tell Ajit, like the time that you lost will be given. Like, it will take care of.
Okay, sure. Also, sir, do the applications for the 15th close on 10th?
Yeah. You have to apply by the 10th. Your application has to be in the system by 10th.
Okay.
Exam can be taken on 15th.
Yeah. Thank you.
So application submission date has to be by 10th. So you submit your application because there's nothing to wait for. I mean, you have to apply first and then take the exam. That's the normal rule.
Sir, can we use iPads for writing exam?
I'm not sure about iPad.
I think
I don't think it will work.
It's doubtful, actually.
Yeah, because it requires there's no keyboard, the camera. I don't know how to keep it, and there's a lot of.
And that too, iPad won't accept many of the applications. Right?
Yeah.
I have a question. Okay, sir. Thank you. How many questions are for the exam?
40.
40 questions.
Yeah.
Yes.
So we need to get like 16 right. Yes, okay.
Yeah.
But with the condition,
negative marking also. Your total score has to be 64.
Yeah, like 16 right. Okay.
Yeah.
Thank you.
Yeah, hi. Will the proctored exam results be displayed immediately after the exam?
I think you should be at the end of the exam. It will show you your score. If it's 64, you passed. 64 and above.
So we don't have to wait for a day or two or something.
That will be the official communication. So when we run this the first few times, then we look at how the group average and how it is performing, and then that 40% number is calculated, and then after 3-4 rounds, then that number sort of gets finalized. But that 40% is not a universal thing. So we all look at relative grading only. So if your
but the score would be
done very
displayed
well and everyone got 60, then the cutoff would have been 60 in there.
Okay, but the score would be displayed immediately. How much we got right or how much we got wrong?
I think so. Yes.
Okay, thank you.
Okay, I have to drop off. I'm really sorry. I have other engagements. So thank you for the time. And if you have anything related to the calculus, please let us know. That would be really helpful. Thank you, everyone. Good day.
If you want to change a slot, please drop an email to admissions at online. If you have a conflict.
Sure, not a problem. I will.
No, I think somebody had put some comment in the chat. I think Kavya, somebody. Yeah.
Excuse me, I have a question. Can I use my driving license as an ID, please?
Yes, can you go ahead?
Huh?
Go ahead, please. What is the question?
My question is that can I use my driving license as an ID card because my ID is not looking good and I'm in Germany now?
Your driving license should be fine.
Okay, thank you very much.
Sir,
Go ahead, please.
sir, this online degree will be applicable for offline campuses for MSc CS?
The 4-year degree should allow you to apply for master's degrees directly. But again, you have to check with which universities you want to apply, and you can confirm exactly with them. In a general sense, yes, the 4-year degree will allow you to apply.
Okay, thank you, sir.
So,
Go ahead, go ahead.
so can we use Aadhaar card as our ID?
Yes.
And sir, I wanted to ask one more question. So as we will be shown the marks just after the exam. So sir, what will be the another deciding factor that will be important for the selection of students?
So the reason you're in this bucket is because you've met all the other criteria, only the math part is lacking. So if you clear this exam, I think the admissions team is just going to review your application once again, and then I think it should be a fairly straightforward thing.
And sir, I wanted to ask one more question. So when I was giving a mock from my laptop, the picture was appearing clear, but it was slightly blurred, although all the information was quite clear. So can I use the camera as the counselor that will be sitting with us will be able to look into it as soon as we upload?
I didn't get the query. You're saying, can you use the laptop camera?
Yes, sir. My laptop camera shows a little blur image. So there will be a person who will be checking all of this and then telling us it's okay, and then we can start the picture.
Yeah, so when you take the live exam, there'll be a live proctor. So if your image is too bad, they may ask you to change or something. But if it's reasonably okay, I think it shouldn't be a problem for this exam.
Okay, sir. Thank you.
I just have one question. Sorry.
Go ahead.
The amount we pay for the course, it depends on the citizenship, but it is what citizenship we have during admission, right? Not during graduation.
That's correct. Yes. Is your citizenship going to change in the next 3 years?
It might.
I think if it does, then you can let us know. I'm not sure what the policy is, because these are very exceptional cases which we'll have to take a call on it. So I can't really comment. But I mean, at least your first semester fee will be based on your current citizenship. This is semester wise anyway.
So any extra class will be taken for the calculus part, like as
we will update you. So if there's something coming, I think you'll get a mail from Coursera with that details.
Oh, okay.
Just like you did.
Thanks. Okay, thanks.
Kavya, if you're changing a slot, no extra payment. If you're taking an extra slot, if you're taking another exam, you do. Main course are also proctored online, yes. So in that case, you need 2 webcams. It's a dual webcam system, and you need a Windows system for the comprehensive exams in the actual courses. For the math thing, it's just a single webcam. You cannot complete the degree before 3 years. You have to take, the upper limit is 6 courses per semester. So it will take you 3 years to complete it.
So
it's actually quite rigorous. So I think people are finding it. The rigor is almost equivalent to an online, an on-campus thing.
Actually, I have Mac. Is that okay?
Mac may have a problem. So as far as I know, it only supports a Windows. You can drop a mail to admissions and maybe they can check it out and let you know. But if you can borrow a friend's one or try to make some other temporary arrangement.
Right.
But for the main compre exam, it won't work. You need a Windows system. It uses a safe exam browser, which doesn't work on Mac. They're trying to find a fix for it, but I think there's a limitation on the Mac side.
How about the remote desktop that I use from a Mac?
So I think we had current batch students try it out, and they said it didn't work. So as of now, it's limited to Windows systems.
Okay.
Can we use Mac for like the online exam?
No, you'll need a Windows system. As of now, you need a Windows system. So I don't know, 3 months down the line, if they find some solution for it, maybe it will be enabled. But right now, it's a Windows system with 2 webcams for compre exams for the courses. Four-year degree will be a BSc honors, and yeah, you can visit the campus while you're a student. You can attend all the campus tests and things like that.
So
Is there any mock test available online in BITS Pilani? Like,
on the campus?
no, online, like for the maths exam.
So you will get a mock test when you get your credentials, but I think the questions are more or less the same as the ones which are shared with you. You'd have a PDF, I think, of the sample test questions. I think it should be similar to that.
So if we clear the math exam this time and decide to start with the course in the next batch 6 months later, do we have to give the exam again, or it will be counted?
You can carry it over. No issues.
Oh, okay, perfect. Thank you.
Dual cam is not required for this test. It's a single cam. We can attend campus classes. If you're on the campus and you want to sit in an on-campus class, you can do that. But all of these, the BSc CS program classes are all online. There's nothing in a campus. BSc honors will cost extra. The details of that are still being worked out. So once we have a formal approval from the Senate, all the details of that will be shared. Attend classes at BITS Hyderabad offline. Yeah, I think you can do it for a short term. Obviously not for the whole semester because you'll have other things going on.
Sir, I spoke to a person from the BITS and they said after we complete this 3-year course, there'll be some 1-year diploma or something sort of like that will make our degree equivalent to the 4-year BA honors sort of thing. Is it?
It's not a diploma. It's a 4th year honors track. So you'll have to take another year of courses.
So that will be the continuation of this course, right?
Be a continuation of this. So there'll be an additional fee and everything.
Okay.
So
that
the
application for this, the application for that will be after 3 years, right? Not now.
Yeah. So once you complete your 3 years, you'll get the option to continue for the BSc honors, or you can terminate. So basically, this as per the new education policy, after 2 years you have the option to drop out with a diploma. 3 years you get a BSc. At 4 years you can get the BSc honors. So that's how it is structured.
Thank you.
So 1 year there is no certificate.
Extra for honors.
2 years. This program is by BITS Pilani. We have an online programs division. BITS Hyderabad, I think you're seeing only for payment because I think our bank account is tied there. So the bank account belongs to BITS Hyderabad. So because our head office is there. You can do the course for 2 years, you'll get a diploma. 1 year, there is no exit option.
Sir,
Yeah.
for honors, we have to pay more and or
Yeah, so those details will be shared, but I think there will be extra payment because the current fee structure is for 6 semesters. 25 hours a week is it's not mandatory, but if you're planning to do the program in a proper way, it's going to take you 25 to 30 hours a week if you're doing the full course load of 6 courses in a semester. If you're working, or if you're doing another degree, or if you have other personal things, you have an option to reduce your course load. You can drop it to even 4 courses a semester, 2 courses a semester, and obviously your workload also, your time commitment will also come down. And so technically you can say for each course you will need to spend 10 hours a week. If you take 3 so the semester is divided into 2 terms. Each term will run 3 courses. So at any given point of time, you'll be running 3 courses parallel, which will be about 30 hours of work. Semester, everything, this is an online program, so there's no offline component at all. So all your quizzes, assignments, exams, everything is online. There's no offline aspect.
Sir, and the hours for these classes will be morning or evening?
I'm guessing you're talking about the live lectures. So the most of the content is already recorded and available on the Coursera system. So when you're enrolled, you get access to the entire course. You can go through those videos, and you can do the reading and everything at your own time. Quizzes and assignments, again, you can do on your own time, but there'll be deadlines for you to submit that. And there'll be around 10 live lectures where you can basically interact with the faculty and solve your doubts and those kind of things. So these are scheduled on Fridays and Saturday evenings, typically after 6:30. You can take a break in between the semesters and then continue with the program. So that flexibility is there. The only upper limit is you need to complete the program within 6 years complete in order to graduate. So 4th year details are not out yet. So once it is out, it will be updated on the website. So 10 hours of is mostly going to be the self-study and readings and assignments. So lecture is just going to be a 1 hour a week component every weekend, and the rest of it is going to be your own. This recording will be shared with everyone who's registered. Books, etc. There'll be textbooks prescribed. So if they are not available in the online library with us, you'll have to procure them. I think the faculty will try to see if those books are available. If not, you'll have to purchase it. Right, I think.
Sir,
yeah,
there is a 10 live lectures in a week or a month.
10 live lectures for a course over 10 weeks. Every week there's one. Your course duration will be 12 weeks, which includes the comprehensive exam. Every course will be of 12 weeks duration.
So, sir, as you said, a term will consist of 3 courses. So, first we'll complete the first and then move on to the next, not like all together.
Yeah, so every term will have a fixed set of 3 courses. So you'll enroll for 6 courses in the semester. The first 3 you'll do in first term. Next 3 you'll do in the second. So this ensures that you're only doing 3 courses at a time, so you don't have additional load.
Yeah, exactly. Those 3 courses that we are doing, will we complete the first course and then move on to the next? That's
No. It's in parallel.
Oh.
So when I said 10 hours per course, you have the option of reducing. So you can say you can register only for 4 courses in a semester. So in that case, it may be 2 courses per term. So it will only be 20 hours per week. It may not be 30.
So the 10 live lectures will be altogether for the 3 courses.
10 per course, 10 live lectures per course.
Okay, thank you.
Yeah. Yeah, so you can take multiple attempts if you're not clearing it. So if you don't clear it this Saturday, you can take up the exam on the next Saturday. So that's why we wanted to have the session today to encourage most of people to take up the exam immediately, because otherwise you'll only be left with a single option. So if you're not submitted an application, do so immediately, and you can register for the exam. On-campus placements will not be a feature of this program because, well, first of all, it's an international cohort. So we have students from all over the world who are enrolled already. But certain other things will be there. So I think you can write to admissions with a specific query will answer. And things are also being worked out actively. So right now we're still, our first batch is still in the first year. So many of these things, such as placements, convocation, all the other things, will only you can take a so you can't take a re-exam for a course. You'll have to redo the course itself. But it's a very unlikely scenario because, well, first of all, we do relative grading. So it's not absolute, like you have to get 35 to pass or something like that. So it depends on how the batch performs. And so if a question paper is really tough, the entire batch will do average or poor. If the question paper is easy, maybe everyone does exceptionally well. So regardless of where it is, someone with a 90 may get an A, and if the question paper is tough, maybe someone with a 50 also gets an A. So it's a very flexible system. So the chances of you having to retake a course are very low unless you have not put in the effort. So if you're doing your quizzes, your assignments regularly, you're doing your studies regularly, if you're preparing adequately well and writing the exam, I don't see a scenario where you should have it. Yeah, so if you're going to wake up at the last minute and expect to clear the exam and clear the course, then that's not a problem. So we are also likely to have another session on Sunday evening with the faculty. So academic queries and all can be answered there. So this was mainly meant for the math thing. I think we diverged a bit too much into the operational aspects of it. So I think if people have queries, you can join our session on Sunday. Again, the details have not been shared yet, so it will be updated on the website and shared to everyone. Yeah, you as a BITS student, you can attend all the campus events. There's no restriction. Yeah, so evaluation will be sort of in that. So I can give you a tentative. So your quizzes will be roughly 30% weightage. Your assignments will be, so you'll have around 5 graded quizzes in each course for 20% weight overall. You'll have 1 or 2 assignments which will be about 20% weightage, and your comp exams will be 50% weightage. Comp exams will be subjective, so it's a pen and paper exam. You'll have to write it on paper, just like you do for your class 12. Convocation details, we're not hashed out yet, so we still have some time to figure that out. All right, I think that's probably most of all the questions. We can, quizzes are 30, assignments 20, complicated. Yeah, so as I said, so if you have more questions, you can join the session on Sunday. We'll get more details about the curriculum and everything like that. The recording will be shared, and once again, please send in your applications, register for the maths test on Saturday. Right? In case you're not getting any information by, say, Friday noon from us, you can go ahead and register for the exam. Just put your mobile number as your application ID on the registration link, okay, and sign up for it. All right, everyone. Have a good evening and good luck with the maths test. I'm sure all of you will do well.